This is the compass-controlled helicopter. It uses a 3-axis magnetometer to control the servos on the flybar. And these servos are hooked up to trailing edge flaps on the hiller paddles so that they can, I'll just show here, so that they can produce a torque in the rotor frame to effect a cyclic control based on its orientation relative to north. So the way that this works is, you see the transmitter here, let's just say I give full forward control. And you can see that if I orient the rotor just right around here, there's no response to the cyclic in forward direction. But about 90 degrees away, I get this maximum response. And as it rotates, if you look closely, you can see the servos going through their sinusoidal motion for typical cyclic response. So that works for left, right, and fore and aft. Now there are some problems with this. The magnetometer is not tilt compensated. So if I give an input and I do this, you can see there's some motion of the servos here. Let's go to a different direction. See, there's a lot of coupling into tilt here. That's unwanted, but it's the simplest way to make this go. Now, I'm going to spin it slowly and show you that the cyclic response is visible even at low RPM. Here we are at very low RPM. Here's forward stick. Here's aft stick. Here's left. And then here's right. And you can see the rotor disc tilting in those directions. Now it's back to neutral. I'll do forward one more time. You can hear the servos cycling here when I give full stick. As it sinusoidally varies. Now, there's no fuselage on this. This is the whole helicopter here. I tried flying with the landing gear, but the dynamics of the landing gear swinging underneath adversely affected the handling, so that didn't work out. Just go over some of the systems that are on board here. Got the 3-axis magnetometer, radio receiver for the RC, an Arduino that does all the math and controls the servos. Onboard battery. This battery is 3S65, 650 milliamp hours, good for about 12 minutes of flight. This is just a DC to DC converter to give a 6-volt output to the servos because they're very fast at 6 volts. And then the speed controllers for each brushless motor. I'm running 6.3 props. And then the main rotor is just fixed pitch, which makes it hard to descend because you have to really throttle back and the handling gets a little squirrely. But it's very simple. And that's it.